A1 की कोई फॉल्ट कोलैप्स हो रही है? एंड गेट पे कौन कौन सी बचनी चाहिए फॉल्ट्स आफ्टर कोलैप्सिंग? इनपुट्स स्टक एट 1 एंड आउटपुट स्टक एट 0, यही बची है। A1 के इनपुट पर ये स्टक एट 1 है, ये स्टक एट 1 है, ये स्टक एट 0 है. So I cannot reduce any further. So nothing will be eliminated here. Talk about this fan out. Fan out के लिए वापस हमें analyze करना पड़ेगा for different faults, and using fault equivalent we removed stuck at 0 at the output fan out branches. Further, none of the fault will be removed using fault dominance. This you can verify, right? So nothing will be eliminated from this set as well. On the same lines, none of the fault will be eliminated on this fan out. None of the fault will be eliminated on A2, or can we eliminate? We have two faults here. Stuck at 0, stuck at 1. Fault dominance collapsing के बाद input stuck at 1 रह जाना चाहिए और output stuck at 0. It means output stuck at 1 was removed due to fault dominance. Therefore, I can eliminate this stuck at fault. ठीक है? A3 पर input stuck at 1 रह गए, output stuck at 0. Nothing can be eliminated further or collapsed further. So I have removed one fault as of now. OR gate में क्या क्या बचना चाहिए? Inputs stuck at 0, output stuck at 1. So ये मेरा OR gate O1. Inputs are stuck at 0 only. Output is stuck at 1. So nothing can be eliminated. Right? O2 may be, this is stuck at 0, this is stuck at 0, and this is output is stuck at 1. So nothing can be eliminated. On this fan out, nothing can further be eliminated. This will be left as it is. So no more fault collapsing till this point. Now comes A4. A4 के input are stuck at 1 fault है, output पे stuck at 0 और stuck at 1 भी है, but I can eliminate stuck at 1 fault at output due to fault dominance. Therefore, I can eliminate stuck at 1 fault at output since I have considered the stuck at 1 faults at input. So I eliminate this. एक चीज का ध्यान रखना, equivalent में हमने output से remove किए थे faults. इन फॉल्ट डोमिनेंस में हम आउटपुट से रिमूव कर रहे हैं, राइट, बिकॉज दिस इज डोमिनेटिंग. ठीक है. सो आफ्टर व्हाट वर द टोटल नंबर ऑफ फॉल्ट्स, पॉसिबल फॉल्ट्स?
32.
32. How many were left after equivalent fault collapsing? कितने थे स्टार्टिंग में यहाँ? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. And after dominant fault collapsing, how many left? I removed 2 further. ये stuck at 1 हटा और ये stuck at 1 हटा, so I'm left with 18 faults now. So what is the collapse ratio? 18 by 32, which is nearly 0.5625. So 56% of the faults need to be tested. Rest can be eliminated due to fault equivalence and fault dominance. There will be one question on this reduced set of faults to be tested for a given circuit in your exam. Is it clear? Any problem in stuck at faults? Some problems on this stuck at fault and fault dominance and equivalence are given at the end of the chapter number 4 from Bushnell. You can work out with those problems, and if you have any issue, you can WhatsApp me or you can ask it in the class. Now we come to the next type of fault, that is bridging fault. Stuck at fault क्या थे? एक particular wire की value कुछ रुक जाती है, या तो 0 हो जाती है या 1 हो जाती है. Now comes bridging fault. As the name suggests, bridging fault means this will require two wires to be bridged, to be connected or shorted, right? So bridging fault exists on two or more wires or lines which are shorted together. Now, not only shorted, but according to the function that is introduced by this short, we can have two different types of bridging fault. That is called AND bridging fault and OR bridging fault. This simply mean, मान लो ये दोनों wire short हुए, and it is said that this shorting results into OR bridge fault, which simply means unlike stuck and fault, the two wires will give you the same value now. Since they are bridged together, they will give you the same value, and the value will be given as x1 or x2. Here also it will be x1 or x2. ठीक है, दोनों जुड़ गए तो डेफिनेटली सेम वैल्यू देंगे, पर वैल्यू क्या देंगे? और ऑफ ईदर x1 और x2. अगर एंड ब्रिजिंग फॉल्ट होता तो वैल्यू क्या मिलती हमें? x1 and x2. Had I have the fault and bridging fault, then the value on this line will become x1 and x2. The same thing here also, it will become x1 and x2. ठीक है, stuck at fault में तो ये value अलग आ रही थी. It is either 0 or 1. Now it depends upon the logic or logic and of the two bridged values. ठीक है, अगर मान लो fault नहीं है, कोई भी fault नहीं है, ना and bridging fault है ना or bridging fault है, then the function z1 implemented is x1 and x2. If there is no fault, then this x2 with this fan out is achieved here. So this function, this gate works properly as an AND gate, and z1 is given as x1 and x2. What will be the output? Z1 if OR bridging fault exists. OR bridging fault है, इसका मतलब इस पिन पर मिल रहा है मुझे x1 and x1 plus x2. इस पिन पर भी मिल रहा है x1 plus x2. So what will be the value of z1? Under the fault F, Z1F will be given as Z1 plus Z2 and Z1 plus Z2, which is nothing but Z1 plus Z2. So the faulty output is OR rather than AND. Right? Similarly, verify what will be the output Z2F for the circuit if the fault exists, or bridging fault exists. The input to this side of the AND gate will now be given as x1 plus x2 due to OR bridging fault. Right? This is faulty input. This is correct input x3. So what will be the faulty output? The first input and the second input. So the faulty output is given as x1 plus x2 into x3, which actually should have been x2 and x3. Right? This is the case of circuit where we have more than one primary output. पिछला जो हमने circuit देखे थे, इसमें केवल एक ही output था हमारे पास. So one primary output. But now here we have two primary outputs, Z1 and Z2. right? So now we look at another approach for finding the test patterns. ये जो अभी हमने किया था इसको हम कहते हैं path sensitization approach. Where we are working with the paths over which your fault needs to pass on, जिसको हमने कहा था observability and controllability. Your inputs should be able to control the fault and the fault should be observable at output. So if we are tracing the path over which the fault is being propagated, we say we are sensitizing the path for that fault. To have another approach so that we can have the test patterns found for bridging fault as well, works with the expression of the output. For example, here, the same circuit that we did in this slide. But how to find the test patterns which will be able to detect these bridging faults? अभी हमने ये तो निकाल लिया कि मेरा expression of Z1 and Z2 will change due to the bridging fault. But how do we detect those bridging fault? So in that case, we use this approach where this is XOR. Since either the fault will exist, then the output will be ZF. If the fault does not exist, the output will be Z, but every time Z XOR ZF will be equal to 1. Either of the two things will be true. Either there is fault or there is no fault. There will not be any case कि Z भी 0 हो और ZF भी 0 हो. दोनों false नहीं हो सकती, दोनों condition true नहीं हो सकती. Therefore, if I have Z as the output without fault for a circuit, ZF as the output when the fault exists, then Z XOR ZF will always be equal to 1. Now, using this, we try to find out the test patterns which will be able to detect the fault F. Here, F is taken as OR bridging fault at X1, X2. Okay? This is the actual Z1 and Z2 without the fault. What was Z1F? X1 plus X2 क्योंकि और bridging fault है. What was Z2F? यहाँ पे क्या मिला था मुझे? X1 plus X2. So this was X1 plus X2 into X3. I'll work for Z1F, you will work for Z2F. So using this expression, Z XOR ZF should be equal to 1. What is Z1? X1, X2. XOR ZF, which is X1 plus X2. This should always be equal to 1. Solve it. This is XOR, so X1, X2 into X1 plus X2 का bar plus X1 plus X2 as it is and X1, X2 का bar. Expand this. This will be X1 bar into X2 bar plus X1 plus X2 into X1 bar plus X2 bar equal to 1 होना चाहिए. This will never be true. X1 and X1 bar will always be 0. So this goes to 0. Expand this. X1 and X1 bar will left with X1 bar X2 plus X1 X2 bar. Correct? Is this correct? इसका मतलब मेरा टेस्ट पैटर्न क्या हुआ? x1 bar x2 plus x1 x2 bar will always be true, which means my test pattern to test the fault f will be 0 1. x1 is 0, x2 is 1 for x1 x2, and x1 is 1, x2 is 0. So this fault f or bridging fault at x1 x2 will require the test pattern P1 is set of 0 1 and 1 0 to detect the fault at output Z1. Is it okay? So the test pattern which will be required to test the bridging fault is 0 1 1 0. Now find out what test pattern will be used to detect the fault at Z2. The fault remains the same. But Z1 पर detect करने के लिए I need only this test pattern. Whatever be the value of x3, this does not matter. So I can put an x here. 0 1x and 1 0x. Now find out the test pattern which will be required to detect this fault at Z2. फटाफट करो. Z2 actually है x2 x3. Z2f बन गया x1 plus x2 into x3. So you simply say Z2 XOR Z2f equal to 1. x2 x3 XOR x1 plus x2 into x3. You have to solve this expression. We'll continue with this solving in the next class. Try to solve it and give me the test pattern to detect the fault at Z2. If you have problem, we'll discuss it tomorrow. Okay, give it a try. Then I'll upload the slides as well. In this slide, you have another question. For the same thing, you have to have the find the test patterns to detect stuck at 0 fault at x4. So this is stuck at 0 fault at x4. Find the expression of z when there is no fault. Then find the expression of z if x4 equal to 0. So simply जो expression आ रहा है उसमें x4 को 0 कर देना, and that would be zf. XOR them and find the test pattern. We'll continue with this in the next class. Any problem today? समझ आ रहा है? This will require some practice. खाली सुनने से नहीं हो पाएगा. You will require some practice. So at least repeat the questions that we are doing in the class. Okay. और attendance कमी होती है, 32 ही जने होते हैं. Please pass it on to other students. Attendance से दिक्कत हुई तो उनका problem है. Fine. Let us meet tomorrow and continue with this bridging fault. Okay. Thank you so much.
Thank you.
Thank you, ma'am.